Now, following with the agenda, we want to welcome Jason Dickstein, President of MARPA, and Felix Hammerschmidt, Head of Additive Manufacturing Solution of Sater.
So yeah, thank you. It's really good to see that there seems to be a lot of interest in 3D printing. So quite a few people here. So my name is Felix Hammerschmidt. I'm heading our additive manufacturing team at Sater, located in Hamburg, actually, Germany. And I'm here now to, first of all, present you with some slides what we do on the technology, where we are, where we see it going. And then afterwards, we will have a good discussion together with Jason, and of course also get the chance to answer some of your questions you might have around this technology. So yeah, let me introduce a bit the technology, but first of all, 2-3 words to companies who all know Sater. So we are part of the Ebiz group under actually customer service, or the commercial aviation business unit, and they're in the customer services. And we are your partner for all things related to material management and supply chain services. So basically you get the proprietary parts from us, but we also have services around Ebiz managed inventories or integrated material services. The reason actually why I want to show you this is basically when it comes to additive manufacturing, Sater is kind of an interface that you as a customer can use to assess also the knowledge we have gathered with regards to the technology over the last decade, basically within Ebiz. Because we are using this technology, we are trying to make it work for our after-sales business. The rest of Ebiz is pretty much focused on how can I get this into the aircraft, serial aircraft, next generation aircraft, stuff like that. For us, it's all about, okay, how can I better serve the fleet that is already there and the aircraft out there. So I think that's important to know. Actually, for those of you not familiar with technology, I would like to start maybe quickly introduce it. So in the topic, it's actually written 3D printing, which is probably the most common term for it. We like to refer to it as additive manufacturing, because 3D printing always has this kind of sense, you know, you have this €500 printer you buy in your do-it-yourself store. It's not what we actually do at Sater. For us, it's a bit really about more real technology, real professional technology, manufacturing parts that are airworthy. So that's why we refer to it, and that's the standard term, additive manufacturing. And looking into the technology, so it's the opposite of subtractive manufacturing. You can see it on the right. In the past, what we did is basically we took a big chunk of metal, we bought it, we machined it, so to generate the final part, and then you had the final part plus a lot of chips, actually a lot of material wastage, and of course you're quite limited with regards to what you can achieve based on the manufacturing technology. And additive manufacturing tries to turn this a bit around. So instead of having a big part and removing material, I start to add material layer by layer. And out there are, I would say, more than 100 different technologies working with polymers, with plastics, with casting sands, but they all have one thing in common, and that's the idea of layer by layer manufacturing. And you can see it actually in an example with a metal powder bed technology here in the video. So you can see here at the moment it's a quad laser system we are running at Ebiz, now melting one single layer of metal powder. Now the next layer is being applied in the video. So that you basically stack them up on top of each other and thereby growing apart layer by layer. And what you can see is actually that you can achieve quite interesting, very complex designs by using this technology. So having this nice comparison of the, let's say, standard milled version of a bracket on the bottom right and the additive solution on the top level. And this is basically possible, or we use it today with polymers and with metals within Sater. So why use it, or what is the promise and the interest in this technology? So when we are talking about aviation and aerospace in general, the main driver today is really this idea of design freedom. So I can produce parts I was not able to produce before. because I can use a very complex design and I slice it into thousands of thin layers. Each of the layers is relatively easy to manufacture, and by stacking them on top of each other, I can achieve a design that is, for example, looking like this. It's a titanium bracket for the flight crew rest compartment of the A350, and it's all about weight saving, functional improvement. So this is one of the promises of the technology, but there's actually a second side to it, and that's what we are looking at Satair. It's not just making the part as good as possible, but about agile manufacturing. The technology offers us really good flexibility with regards to manufacturing because we don't need any tools. It's a highly digital technology. And it can be much, much faster than, for example, casting or forging technologies, injection molding technologies. And that's why we are looking at it from Satair point of view, because we want to improve our supply chain and make it future-proof with that, especially when we are, for example, talking out of production aircrafts. So 30 years or something after production of an A300, when it stopped, it can be quite challenging to keep these supply chains alive. And this technology offers great potential to improve this. And it's actually one of the examples. It's a titanium tool. We are selling them since 2016. You can see, so we also improved the design based on customer feedback. It was about reducing the weight, and actually there was an issue. The original design was quite edgy, so there was a risk that you scratched the aircraft during maintenance. So we came up with this new design, which is better looking, I would say, and much rounder. And it's being on sale since 2016. Was probably one of the first tools we've done. So to sum it up, why are we using it for our industry? It's really about efficiency in small volumes. So when we're talking cars or something, it might not be the right technology to go for, but in after sales, where it's a highly erratic demand, low volume typically, this technology offers really good potential because the printer basically doesn't care if you produce today a bracket, the next day a cup holder, and the day after something else. You don't need any specific tools, and I can even produce different part numbers in one build job, which makes it, in the end, even if you do it right, efficient down to the quantity of one, which is very interesting for our low volume business and after sales. In the end, we can offer reduced lead times because we don't need to produce any extra tools. You can mostly directly start out of a digital file, which is then, of course, important for spare parts supply. And in the end, increases the availability of the parts, but also reduces stocks, which is pretty interesting and important, as we see stock levels mainly rising all over the world at the moment. As I said, yes, so no costly manufacturing tooling, that's important. We have the opportunity to improve the design as well, but I wouldn't say that this is the main driver on after sales. For us, it's more about availability. And one thing that it ultimately leads to, and that is again interesting, of course, for the airlines, is mass customization. So you can do low volume productions for your cabin parts to differentiate, for example, from your competitor. And we will show you a few examples on that as well. So what we do with the technology at Satair today is basically we have 4 product lines developed over the years that we are basically growing all the time at the moment. First of it all, it's customized parts. So really customer coming to us with a specific request or an issue where they don't find a solution on the market, and we analyze together with them, okay, can we do this with 3D printing? Could this be an opportunity? And I will show you some examples in a second. Then we have flying parts. That's really all about out of production supply chain issues where we might have issues with the original manufacturer, but we still have to provide those parts to customers, of course. So we look, okay, can we improve this by using additive? And then, as I already told you, we have tools and ground support equipment, which is, I would say, a bit of our playing field because certification burdens are much lower than for flying parts. So there we can really use the latest technologies, make use of it, try them, and improve customer experience, I would say, with the parts. And something that we've recently added is actually trainings as well, because we see a lot of interest in the market, but also a low level of knowledge. And people often don't know where to start. So that's why we decided, okay, let's train our customers also to better understand how they can use this technology. And something I really want to point out is, for us, it's not a technology. Let's say we say, okay, this might be something we might do in the next couple of years. It's really something we are delivering already today. And what differentiates us, I would say, from many people in the market is when you get those parts from us, they are fully certified for use on your aircraft. So you get them with an EASA Form 1, you install them, and you basically use them as if it would be a normal spare part. To be honest, if we're not talking about customized parts, if it's a tool or a spare part, ideally you just get an additive part and you don't even know or care that it's additive, because you know it's about the purpose of the part. And I'm very sure quite some people in here have already ordered additive manufactured tools, for example, from us and don't even know it, which is fine. So let's dig a bit into the different product lines. So just some examples that we did in the past on customized solutions we are allowed to share. This is one from A300, so we are also using definitely this technology to support our legacy aircraft. We were contacted by a customer that is running this as a cargo freighter, and they had the issue that the original cup holder in the cockpit, you can see it on the left, it doesn't fit any beverages or cans you get today as a pilot, because it was designed in the 70s. So you can see it's pretty small. I can tell you, the Starbucks cup doesn't fit in there. So what does a pilot do when he gets the coffee in the morning? He puts it somewhere in the aircraft on a exactly on a more or less leveled plane or area, and then they start. And in regular instances, the coffee starts to spill and is of course causing issues in the avionics and the electronics, so really causing maintenance costs. So they approached us and said, okay, can you do something about that? And yeah, we were quite happy, and you can see the new design actually that we came up with 3D printing and delivered this to the customer, because it's a low volume production for an out of production aircraft, so you don't necessarily want to go for injection molding or anything, and customer is happy, and yeah, so are we. And another example, an airline came to us, they want to remove the in-flight entertainment system on some of their aircrafts. So suddenly there was a gap or hole in the armrests of the aircraft, and they needed it quite quickly because the aircraft was already scheduled for maintenance. So they asked us, okay, can you provide 260 of those caps? They already had a design in mind, and we did it together with them. Did basically an on-demand production of 260 parts that they were able to install within, I think it was 8 weeks from first request to deliver of those parts. And then they started flying with it, and actually they called us 5 days later because we had a snap fit printed to put it in there. It was their design idea in the end, I must admit. And they were calling us and say, okay, we are losing those covers because people tend to steal it. So we need more. What we did then is actually we just changed the design within 2 days, include a screw, exactly, and delivered another 260 of them. They installed it. Everything is fine since then. And just imagine you would have done this with an injection molded part. Changing the injection mold would have taken you weeks, if not months. So what do you do then with the aircraft? Flying around with 260 holes in the armrests? Doing some duct tape? I don't know. So that was quite good project as well. Then we have just flying parts. So this is really something, no customer request in the backhand or anything. We just saw, okay, we have these lavatory signs on the A380, 330, 340. You might have seen them before. Problem here is it's injection molded part. So if you want to buy them from your supplier, he will basically just offer you like minimum order quantity, 50 or 100 of those parts. And we have them for, I guess, 30 or 40 different colors on stock. So basically we have a big shelf just with those covers, which is not very efficient because, of course, the number of sales are also quite low. So what we did here instead is switch to additive manufacturing. We print those parts on demand and then just paint them in the color we needed, and thereby basically reduce the stock to a minimum and still being able to cope with the demand by the airlines. And this is just another example for a tool. So here it was also about integrating and optimizing the design. The original part was done by 4 different metal parts in an assembly. It was edgy again. You use it in your cockpit actually to lock the flap slat system during maintenance. And there was the feedback that you sometimes scratch parts of the cockpit with the edgy metal part, which is of course then causing a high follow-up cost. So what we did is here we changed to polymer technology. We printed this all in one, so no more assembly, and we even integrated like part numbers and you can see the scale. It's all printed in one shot, so you can have a very nice and neat tool that is performing better than before. And yeah, just maybe to highlight, whoever thinks that this technology is not around yet, I think we sell an additive tool basically every day by now. So this is really a quite big growing product line at the moment. And then one other thing we do, as I said, there's a lot of interest in the market, but the question is always, how do I start? What are the problems? Shall I buy a printer and just print something, or is it what else do I need to take into account? Does it actually make sense for me? So as we get those questions quite often, we decided, okay, let's go for training, and by now we're offering public and tailored courses actually. If anyone is interested to visit us in Hamburg, feel free to do so. That we will be digging a bit deeper in 3 days on what this technology is about and how you can apply it in after sales for aerospace. And then also maybe look into the future, where we think this is going. So something we really see as a big potential is also the collaborative or integrated approach here. Because if you see today that there is an issue on your aircraft, or you have a, like the gap, there's basically no part for it available on the market. I think 3D printing offers a good potential for some of the issues we see and some of the problems we have to be a solution. And I can just, tell you feel free to contact us on this. But of course, we see also that many of you will be developing own solutions, which is absolutely fine, because in the end, we want to foster the technology as well. So just imagine you then have this nice new part. It's fully certified. You have done the production. You can install it on the aircraft. So the question then that comes to my mind actually is, okay, why not share this with the industry actually? Because there will be for sure other operators out there that have the same issue, that have the same aircraft. So something we will be fostering by the end of the years actually. So we will be launching an Sada.com marketplace for used parts, for components, but also for additive parts. So there will be a special section on additive parts where you can basically get full visibility and order all the additive parts that we have been developing at Sada together with Ebiz. But also we want to give others the chance to actually highlight and offer their parts, their solutions to problems that probably others have as well. So you, as a customer, you can access basically the full scope of potential of additive manufactured parts here. As a OEM or airline that does own printing, you can increase your market sale by having another sales channel basically and making this accessible to others as well. So this is something we see as a good first step to really increase the number and usage of this technology. Where does this lead us in the future? For us, it's really about when we have the critical mass, we can think about, okay, how can we use this technology, for example, to do distributed manufacturing, which is basically the promise that everybody is looking for when it comes to spare part production. So instead of, having the part on stock in Hamburg and sending it to Singapore, can I just print it when it's needed in Singapore in a warehouse, for example, and deliver it directly? And I think this is all about having the critical mass of parts available. So let me quickly summarize. Where are we today? So as Sada, we are offering more than 200 part numbers by now. You can get them basically on airbuspares.com. So ground support equipment, flying parts as well. And we are really heavily pushing now at the moment to scale this number and to improve the internal and external processes to basically at least in zero, so to come very quickly to more than 1,000 parts and to grow the application of this technology. And to quickly summarize, so for us, the technology is really, it's already here. So we are developing, we're delivering those parts today. With SADA, we are leveraging the design and manufacturing capabilities we have been building up with the technology within Ebiz over the last decade to make it accessible for our customers in the end, which is you. And we see a tremendous growth in the technology in the future. So there are new technologies ahead of us that promise much, much higher productivity, lower costs, which will again increase the scope of applications. And ultimately, we really see this as a game changer for our overall supply chain setups and the way we treat customization and out of production in the future. Thank you.
Well, this is some pretty exciting stuff that Felix is doing. And actually, Felix and I wanted to thank Louis-Philippe and Santiago and Juan and everyone else on the Alta team for inviting us to be here and also for recognizing just how exciting that additive manufacturing is. Felix, you've been identified as one of the leading experts now in additive manufacturing, so we're pretty lucky to have you here. Can you tell us how you got here? What got you into additive manufacturing?
Yeah, for sure. So I started with the technology 6 years ago when I joined Ebiz, actually, in after-sales customer service at that time. And I was part of the team that at that time identified the very first spare part, actually, and made it or certified it for additive manufacturing, which, by the way, was an A300 part, so out of production where there was no supply anymore. And that was the very first part, actually, that even within Ebiz was certified for the technology. And from there, it basically grew quite quickly over the last years. So in the last, I've been working with the technology now for 6 years, inside and outside of Ebiz, also doing some automotive application in the meantime, and now being back at SADA, pushing this for our after-sales market.
I know there's a number of people in the audience that are going to want to go to your July 23rd through 25th session in Hamburg. For those of us, though, that can't make it and can't invest the 3 days in Hamburg to learn about how to get into additive manufacturing, can you give us the cliff notes, the thumbnail sketch of how a company can begin to use additive manufacturing in their own operations?
Yeah, for sure. So first of all, I think what is important to say, it became much easier than when we started in 2013. There was no standards, no material specifications, no process specifications. You could just buy a printer where the printer manufacturer would tell you this is great for additive and for aerospace. And then you're basically left alone. So we really had to tinker around, work with it, master the technology, understand it, write all those specifications. This has changed over the years. So there are first printer material combinations available where you get a good data set, which is also agreed and accepted by FAA and EASA, so that starting with the technology has become much easier than it was years ago. Other than that, I think from an internal perspective, it's really about finding first applications, some pathfinders, showing that there is value with the technology. Basically to get the management buy-in. This is in the end always highly important, I think, to then grow the applications. And what I can only recommend today is also something that wasn't existing in 2013. There are now a few quite specialized companies out there in aerospace that have a good knowledge on additive manufacturing. So I think it's definitely worthwhile to partner with them, to work together with them, instead of that everybody's doing it in a silo and basically starting from scratch, defining material specifications and process specifications, because that in the end will be quite inefficient, I think.
So you mentioned demonstrating value, and I know for everyone in this room, the cost-benefit analysis is always going to be vital. One of the other things that's related to that is the practical constraints. You know, what can we use it for, but also what can't we use it for? What sort of practical constraints exist today for additive manufacturing?
That's a good question, actually. So I think even still today, one of the things that mostly hinders us from really scaling it is the whole topic around certification, because there is still a lack of knowledge in the engineering departments. There's a lot of cautiousness, which is of course good, because this is a highly safety critical industry. But this is really causing us issues in the beginning. So our first part, it took months, if not years, to certify it. But it's really all about making this knowledge available, so setting standards for the material, further process specifications, getting your expertise internally, partner with somebody maybe that can provide it as well, to accelerate this process and thereby get the parts done much quicker. So even us internally, we are setting up now a totally new certification process for additive manufactured spare parts, because we saw, okay, the way we have done it in the past does not cope with what the technology is possible or able to do. We're not yet done with that, but we're working on it and pushing the boundaries here. I think that's one of the constraints, and of course there are technical constraints as well. It's not that this is a solution for everything. So it's not that we can print like a whole aircraft. So printer size is for polymers, it's in the area of up to 1 meter. And also, if you select the wrong parts in the beginning, you might be quite desperate, because you see, okay, it's like 20 times more expensive than the injection molded part. What should I do with this technology? It's really about finding the right applications and starting from there, because it won't be, as I said, the solution for everything. It will be another great tool in our toolbox, I think, that can solve quite some pain, but not everything.
So I'm hearing both certification constraints and also some practical constraints in terms of what it's well suited for. I'd like to get back to the certification, because that's, of course, something near and dear to my heart as a lawyer. But first, I want to ask you about the practical constraints. You'd mentioned both polymers and metals when you were speaking earlier. The idea of being able to do 3D manufacturing or additive manufacturing with metals is just intriguing and exciting, and obviously it's also really useful for our industry. Where are we with metals today?
So I would say metals are actually already here. What you can see mostly, it's polymers. There are a lot of applications in the cabin. But as you saw, we are selling tools since 2016 in metals. And actually at Ebiz, we just recently passed the process qualification for 3D printed titanium, which means that we can handle the process now like if it would be just another manufacturing technology. So like it would be milling, casting, or something else. So there's the full data set behind. And A350 is by now equipped with some titanium metal parts in serial production. And my team is currently working on the first titanium spare parts, actually, that we will be launching then as soon as possible. Also to the market. So we are really getting there. It took us quite some time with metals, but we have now really come to a stage where we are able to increase the amount and grow it.
So now that you're getting into the titanium alloys, what do you see as next? Where do you see metals going in the future?
So I think there's a very big growth potential. So of course in serial production there's also a lot to be gained. This is why you have to master the technology basically today, and not when you start developing the next generation aircraft, because then it's probably too late. Either the technology is ready already and you can implement it, or you will have to wait for the next one. And in after sales, it's really for us, it's out of production, it's casting parts, it's forged parts, all the stuff that takes long and is inefficient to produce in very small quantities, where we see good potential for the technology.
Stepping back to what you were saying earlier about the certification challenges. Obviously, certification challenges, you're going to see the design approval challenges and also the production system challenges. And to me, some of those production system challenges are the most interesting, because at a high level, the process level, we can say that all manufacturing has supplier control. But at a procedural level, the procedures for supplier control are going to be different than the procedures for or the procedures for supplier control for additive manufacturing might be different from the procedures for supplier control for casting or forging or any other manufacturing mechanism. Where do you see the major differences in supplier control, production process control, operator control? Where are the major touch points, I guess?
Yeah, that's actually interesting because there seems to be a lot of confusion and questions around this. So how can I certify and qualify this technology and my supply chain and stuff like that, which is probably linked to the fact that it hasn't been around like casting or machining for like hundreds of years, and there's a broad and vast majority of data and knowledge available. But in the end, I think it's just another manufacturing technology. So the way we deal with our raw material supplier or the supplier of the machine or even maybe a printing supplier is basically from procedure point of view, it's exactly the same as you would do with any other casting supplier or a machining supplier. The only difference there is probably okay, what are my key parameters and how do I control them, or what are the boundary limits? For example, if you're talking about a metal powder, for sure you have to have other parameters you control at your supplier than it would be if it's a casting part. And this is basically what also took us some time to really identify, okay, what are the key influencing parameters for the process, where are the limits that we allow, for example, for powder with regards to size, chemical composition, or other technical parameters. This is really something, I think, where standards are needed and more knowledge just has to be gained, because it's pretty inefficient if now every airline around the world starts to research on, I don't know, powder particle sizes of metals. Probably that's not the way it should be, but with this technology maturing and some companies really pushing it, I think there will be more and more standards, and this is then making it easier for all of us.
Do you see a future where your company might develop the data set associated with the production and might actually lease that data set to air carrier customers that would be able to produce tooling or possibly even parts? And if you do see that as a future, what do you think are some of the challenges?
Yeah, it's definitely something we are thinking about, because whenever you think about additive manufacturing in logistics or in after sales, there is this idea, the dream of, okay, have this distributed manufacturing, have the airline print the part on its own when it's needed, and basically just provide the data set instead of the physical file. So yes, it's something we are thinking about. It's not yet there, because for sure there are quite some constraints with regards to quality assurance and how do I make sure that the data transfer is safe, that it works. There's also a commercial aspect, of course, because I don't want to give out data sets and then they will be shared and everybody's printing parts for free. It's not so nice for the person who has developed it in the end. This is definitely something we are tackling, that we are working on as well. Because we see good potential. And if we do this, it has to be done according to a material and process specification at a qualified supplier. The data set that we will be sending around the world is before, of course, validated in one of our reference manufacturing shops that we have internally at Ebiz, to make sure that the data is fine and valid and does work if you stick to the boundaries set by the process specification. And then I definitely see the chance to have this manufactured also abroad or distributed. I don't think it will happen very quickly, for example, for metals, because that's quite special. But for example, when we're talking about ground support equipment and tools, I could see that happen rather sooner than later.
So you talked about process control, and it sounds like some of that process control is definitely coming from the design side. Do you think that there is going to be more forethought that has to go into process control on the design side than for other forms of manufacturing? So oftentimes, for example, you'll have a design side, and then they'll kick over to the design of the production side. The production side may do a lot of the process control development and design. Do you think that's going to shift back over to the engineering side, to the design side, with additive manufacturing?
So I think it's the case today. So today, it's from an engineering point of view, it's a more challenging technology than others. So there are a lot of things that the engineer, also on the design side, has to take into account with regards to quality, orientation of the part, design itself to make it as efficient as possible for technology, which has direct impact on the cost in the end of the part. But I see it shifting in the future because it will become a commodity technology as others are today, and then you are just designing for additive as you do today for injection molding or machining, because also injection molding and machining, of course, has some, let's say, process specifics you have to take into account. So today, yes, it is a bit more of a challenge, but I think it will definitely become more and more standard, which is good because it will foster the overall growth of the technology. It's a bit like CFRP was like 20 years probably ago.
Where do you see the most growth? Obviously, in the room, we've got some manufacturers represented. We've got air carriers represented. Historically, additive manufacturing's been looked at as a manufacturing technology, and I see a lot of manufacturers beginning to use it. Do you see that as the growth area, or do you think that we're going to see a lot of growth in MROs and air carriers using it to produce their own tooling, to produce their own parts even?
I think we have to differentiate. So one of the growth drivers definitely will be serial application with a next generation program. That will definitely fuel the whole value chain, basically up to the OEM, to incorporate more and more of those parts. But I also see very good growth potential actually in the let's say downstream value chain, so around MROs and airlines. I don't think that airlines will buy metal printers and produce their metal spare parts in the future on their own, because it's probably not efficient, and it's not their business model. It's about, you know, keeping those aircraft up in the air, running them, sweating the assets. But for sure, I can imagine that more and more of them will be using printers to do these kind of customization, quick cabin replacement, stuff like that. But the biggest growth I definitely see inside the OEM and maybe the MRO business. So I don't think that you shift from a carrier business model to a production business model. At least from my point of view, it doesn't make much sense.
Is there anyone in the audience that wants to ask some questions?
Thank you. The first 3D printers, you can look the layers and you feel that it's made with several layers. But I see you have a very smooth surface. How you get there? Is it a matter of the new technology of the printer, or you do something else?
Yeah, that's true. Depending on the technology you use, you might have a not so good surface finish directly after the printing. So what you would need to do then is post-processing, actually. So there are different ways of improving surface quality before you apply the paint. That's what we do today. And in parallel, actually, we are working on new technologies that come out directly of the printing process and in a much, much better surface condition, so that you just need to apply paint. So there is, for a cabin part, typically definitely still this next step. It's not that you get the final part directly out of the printer. You have to paint it. But still the process chain is quite slow, quite short, and can be very quick. Yeah.
This additive manufacturing, what has it done to the test and certification? Has there been any changes? Has it got any steps saved, got it any easier, or actually has got more difficult? Or is it the same?
I would say it's pretty much the same. On metal side, it got maybe even a bit more complicated for the time being if I compare it to cast and forge, which is just due to the fact that that we don't have these data sets. So there is not the experience of hundreds of years. And that's why at the moment everybody's a bit more cautious. There's more testing, there's generation of data to show this this compliance. But this is really just, I would say, now at the starting point. And I think what is important to highlight, it's really a top-class manufacturing technology when it comes to material properties. So, for example, if we look at the specification of our titanium parts we produce for airworthy applications, the mechanical properties are similar or above forged titanium. So we are not talking about, let's say, any kind of parts you just put somewhere and they don't see any loads. It's really up to critical components you can use. Yeah.
And Ahmad, there's some other areas where I think additive manufacturing has influenced the certification process. One area where it's been influencing the certification process is in the PMA parts for rapid prototyping. PMA manufacturers who might not be using additive manufacturing for their production runs are using it for rapid prototyping in order to basically establish and confirm geometries and other factors like that. Another place where this is affecting certification, though, is within the authorities themselves. Organizations like the Federal Aviation Administration, like the European Aviation Safety Agency, it's causing them to relook at their production approval mechanisms and the elements of their production approval mechanisms and kind of reconfirm what it is that they want producers to do without regard to what the technology is. I know the FAA, for example, has spent an awful lot of time looking at, does additive manufacturing fit into the FAA's production regulations, Part 21, Subpart G? And I think the conclusion has been that at the process level it does, but as with every different manufacturing mechanism, at the procedural level, you have to develop procedures that match the technology in order to fit into the larger process.
I would like to know,
Back one.
So I would like to know, additive manufacturing would actually move further the, let's say, the production possibility frontier. You know, you could produce complicated parts that are not available right now. Do you think that will come with economy of scope too? I mean, being producing this really complicated part in an efficient or economic way.
For sure, yeah. I mean, when we look not into spare parts, where you typically try to replicate the design that is existing, we see it in serial application for sure as being one of the drivers for some OEMs. So we see it with the jet manufacturer or the engine manufacturers. They are investing heavily because size, material, complexity, fluidics, flows, they all have it all in their product. So they can really gain advantages also on the efficiency side of the engine. We also see it a lot in hydraulics and fuel systems, where there's a lot to be gained, and a lot of work currently being carried out in the preparation of next generation of aircraft.
And ultimately, one of the predominant characteristics that's considered in design is going to be weight. And under current manufacturing technologies, or I shouldn't say current, under yesterday's manufacturing technologies, before additive manufacturing, you had parts that, because of the manufacturing technologies, basically had extra metal. They didn't need all of the metal on the inside because they didn't need that much strength, which means that if we had a way to actually build the part hollow, we would have done it, because it's just added weight that's unnecessary. Now today, you can take those parts where that added strength is unnecessary and actually redesign them. You can design them as honeycomb, you can design them as hollow, depending upon what the needs are of the part, and you can lose some of the weight of the part without losing any of the effectiveness, without jeopardizing safety, and in some cases, actually increasing the reliability on that part. So, I mean, some of the things that Sater is doing with these parts are just amazing.
Hello. Thank you for your presentation. I have a question related to inspection. How do you inspect the part? What kind of NDT methods do you use? And the second one is, do you always have, or do you have a machining step before being able to inspect the part?
So to answer maybe the second question first, a machining step is not necessarily always required, especially for polymers. It's often or normally not done. For metals, it can be often the case because interfaces or something with tight tolerances, they get pre-machined. And to the NDT, it's basically on polymers, it's not such a big topic. On metals, it's mainly CT scanning for the time being. Because, yeah, as I said, it's about gathering those data, and this is exactly what you asked. So in the beginning, it's I would say higher requirements with regards to NDT than we see it with casting or forged parts today. But I mean, there are clear curves behind, so the amount of CT scan will be drastically reduced as soon as there's more data and more parts available. But it's not that we have developed anything new here, because in the end, also those parts comply with the overall process chain of manufacturing, and we are using existing technologies as you would also use them, for example, in casting.
Bueno, una pregunta más.
What are some of the technological limitations that are? I mean, it seems like whenever I hear about this, it can do everything, and so I'm like with some of these very unique, say, metal alloys and things like that. Where does it get to where, hey, you know, that's beyond the limits of what we're talking about with this technology? Because I always hear about, oh, it can do everything, it can do metals, you know, and I'm not clear on kind of where the limits are on the technology.
So I would say the main limitation today that's also easy to understand is really size. It's not that we can't print like meter-long parts today. So metals, typically what we do today is in the area of 400 times 400 times 400 millimeters. We can go to up to a meter roughly. Some other technologies even a bit larger maybe, but they are more in a development phase. So size is definitely one of the main limiting factors. When it comes to materials, actually, I think we are just scratching the surface at the moment, because what we have been doing in the past years with the technology is replicating materials that were already there. Can I produce this cast titanium with additive? Yes, I can. Can I do this aluminium with additive manufacturing? Oh yeah, I can do it as well. What we see now is actually being big material development companies investing heavily into the technology, because they see that they can use the unique capabilities of the technology to manufacture materials that were not manufacturable before. And that can, I think, in the medium to long term, really change the way also we manufacture parts. I think one of the best examples, just like 1 week old or something, there's a company now being able to print diamond-like materials, so super hard materials, which could ultimately change the way we manufacture cutting tools. Because today the biggest problem is with those materials, once you have them, you can't really shape them anymore because they are so hard. If I directly can manufacture highly complex parts out of this extremely hard alloy, I think we're really just scratching the surface of what could be possible with that in the future.
Bueno, muchas gracias a Felix y a Jason por su presentación, muy interesante. Los invitamos a almorzar en el Salón Tulum, cortesía de Delta Tech Up. Los esperamos a las 2:20 en el Salón Maya. para hablar de the future of